Right now, there are exactly 800,000 galaxies on the screen, and this map is publicly available and free. According to a June 5th announcement by the Cosmos Web collaboration, you are now looking at the largest map of the universe ever created. In fact, this is the modern version of the moment Ptolemy's 1,400-year-old map convinced Christopher Columbus to sail into dark seas. Only this time, it's the universe. For the bold, exploration begins now. To understand such a galaxy map, let's place the deep space image before us on a timeline. The brightest and sharpest hexagonal celestial body is the closest to us. As you can see, it hasn't shifted toward red at all. The less it shifts red and the more vivid its color, the closer and younger it is to us. From its light, we also know it's a star. Next, take the object directly behind it, slightly redshifted and much dimmer than the star. If we look at its light magnitude and redshift, we expect it to be much older and more distant than the star. From its shape, we can say it's a galaxy. Then take a very faint, deep red object and place it on the timeline. Judging by its redness, this is the oldest and farthest object in this image. The crux is, redshift indicates the object's age, how close it is to the Big Bang, and its distance from us. To grasp how impressive our universe's largest map to date is, let's make a simple comparison. The red circled point on the screen is our galaxy, the Milky Way. This galaxy spans about 100,000 light years, meaning even at light speed, it would take 100,000 years to cross from one end to the other. In kilometers, that's approximately 946 million trillion kilometers using our galaxy as reference. When we imagine the entire map before us, the current view is truly breathtaking. Even in a tiny patch of sky, 800,000 galaxies have been detected. And this is one of the most comprehensive sky maps in modern human history. Until now, our deep space images have usually focused on tiny pinprick regions of the sky. But Cosmos Web changes that perspective. This time, a 0.54 square degree area was surveyed. What does that mean? Instead of a single point, we're looking at a sky region as large as 3 full moons, far beyond typical deep space observations. And here's the stunning part. The James Webb Space Telescope observed this region for a total of 255 hours. Imagine the sky as a football field. COSMOS Webb scanned only a postage stamp-sized area on that field. But surprisingly, even in this tiny area, about 800,000 galaxies were detected. According to some sources, this observation covers only 1/80th of the sky. So we're looking at one piece out of 80,000 puzzle pieces. But it doesn't end there. This single puzzle piece alone comprises over 10,000 4K-resolution images. Indeed, that one piece is made up of 10,000 smaller puzzle pieces. Scientists stitched these pieces together one by one to produce today's magnificent image. Moreover, this isn't just a spatial map. It's a three-dimensional slice with depth and time. These observations trace back 13.5 billion years to the infancy of the universe. In other words, we are seeing the state of that postage stamp patch as it was 13.5 billion years ago. The most frequently asked question is, how can light from a galaxy formed 13.5 billion years ago and another formed 8 billion years ago reach us at the same time? The answer is actually quite simple. Imagine two vehicles moving at the same speed. Say 100 kilometers, H1 is 200 kilometers away. The other is 100 kilometers away. If the farther vehicle left 2 hours ago and the nearer one left 1 hour ago, they would arrive at the same time. Light behaves the same way. Light from the more distant, older galaxy started its journey earlier, while light from a nearer, younger galaxy began later. Yet they can still reach our telescopes at the same moment. That's why we can observe light from galaxies formed at different times simultaneously. These lights, arriving at JWST's giant mirror, were then processed, cleaned, and cataloged over a 2-year analysis period. The result? We now hold the most comprehensive and deepest map of the universe in human history. Some may ask, so what? Surely Ptolemy heard the same question 1,900 years ago. After JWST made these observations, the raw data was processed on supercomputers for 2 years. Billions of data points were cleaned, aligned, and made meaningful for scientific analysis. Not just stunning images, detailed information was extracted about each galaxy's structure, brightness, age, and chemical composition. For each galaxy in the catalog, a kind of cosmic identity card was created. Each card includes not just a photo, but its distance from us, hence its age via redshift value, its star formation rate, morphological type, and total stellar mass. This detailed data set for objects is an invaluable treasure for comparing the evolution of the universe across different epochs and understanding which types of galaxies formed, when, and how. Thanks to this information, cosmological models have begun to be re-examined. For example, we previously had very limited data on galaxy rotation directions. But COSMOS Webb observations revealed that about one-third of observed galaxies rotate in a counterclockwise direction. This suggests the universe isn't entirely random and strengthens some scientists' long-held rotating universe hypothesis. Some theorists have even taken this further, suggesting our universe might have originated from within a black hole. Of course, this remains speculative, but the high-quality data provided by telescopes like JWST has made previously daring ideas more discussable. The James Webb Space Telescope is one of the most ambitious scientific inquiry projects in human history. After 25 years of meticulous work and enormous budgets, the telescope was successfully launched and opened doors to discoveries that will radically shake our understanding of the universe. The most interesting fact? JWST's data is completely open. So if you have powerful computing resources and expertise to interpret the data, you can access and analyze it from anywhere in the world. With such a vast data treasure in hand, researchers from different countries join forces. In collaboration across 12 countries and dozens of universities, Cosmos researchers work to process and catalog Hubble and JWST data. This massive team of approximately 200 scientists has produced the 800 galaxy map on your screen and made it publicly accessible. Leading this comprehensive mapping and cataloging effort is Astrophysics Associate Professor Jehan Sevim Kartaltepe. We sincerely congratulate her once again. So how is such a massive mapping completed so suddenly? In 2016, using the 2.4-meter Hubble telescope, galaxies from 500 million years after the Big Bang were rarely or never observed. That situation aligned with cosmological models at the time. According to those models, galaxy formation should take time after the Big Bang. Gravitational collapse, structure formation, star ignition. Everything should develop step by step. Then came James Webb. With its massive 6.5-meter mirror and prime location, Webb could see deeper and further into earlier times than Hubble. So how did Webb detect those invisible galaxies? The answer lies in redshift. Because the universe is expanding, light from a very distant galaxy stretches like a rubber band over its multi-billion-year journey, shifting from visible to infrared wavelengths. Hubble observed primarily invisible light, while James Webb's huge mirrors and sensitive sensors are designed to capture that light, tired, and reddened into infrared. This way, Webb captured the faint traces of some of the earliest galaxies in the universe that Hubble missed, revealing nearly 10 times more galaxies than predicted. In fact, this discovery was the first major blow to existing cosmological models. Until Webb, scientists believed the first galaxies could only form around 400 million years after the Big Bang. But Webb's data showed galaxies emerged as early as 280 million years post-Big Bang. Moreover, these early galaxies were much larger and more developed than expected. As a result, James Webb practically struck at the heart of current cosmological models. Science has often been defined as a measurement problem, but this time the measurements were so precise and clear that even enthusiasts like us can easily notice their impact. So what's next? The COSMOS Webb team aims to expand Webb's observation field tenfold. If this happens, the galaxy count in the map could reach 8 million. Such a data set would be revolutionary not only for tracking galaxy evolution, but also for testing dark matter distribution and the role of dark energy in cosmic expansion. Perhaps what happened before the Big Bang lies hidden in this new map. Science lovers, today we brought you a very important development. Please like our video, subscribe to our channel, and support us so that science can reach more people. See you in our next video.